Good morning, everyone. Welcome to this episode of Beyond Max Q. I have two people here today that I get to interview. I'm really excited, the co-founders of Outbound Arrow. I've had the privilege of working with them in the past, and they are some of the most hardworking founders. I know that's kind of a cliche, right? All founders are hardworking, but they truly have grit and determination and are building something very, very special. And so I'm excited to be able to interview them today and hear their story. And so we have Ian and we have Jake. And I don't know who wants to go first, but with that, please feel free to interview or introduce yourselves.
Sure. So I'm Ian. I'm the CEO and co-founder along with Jake here. Um, we are building next generation aircraft is our vision, and a lot of that hinges on a need to develop next generation manufacturing to support a new era of aircraft.
I'm Jake. I'm an engineer. I've worked in aviation and aerospace for about 8 years prior to starting this, and I wanted to bring a lot of the excitement that we had in the new space industry back to the aviation industry. I feel like that's been missing a lot.
Yes, no, I love that. That's great. And I would love to hear a little bit about what you're building. I think you guys get so excited when you talk about it because it's your passion. And so I would love tell us about your company. Tell us about what you're building.
Yeah. So, as Ian mentioned, we build next generation passenger aircraft. We founded Outbound because we spent a lot of time looking at the aircraft industry, wondering kind of what the problems were in there. And then we also spent a lot of time looking at the space industry and wondering, like, how did this industry move so much faster? How did the new space industry move so much faster than the legacy aerospace industry? In my career, I've worked on commercial aircraft. I have hardware on the 777 and on the 747. And then after I left Boeing, I went over to the rocket industry. And when I was building Terran 1 at Relativity Space, um, I started to realize that all of the processes that we were using, the tools and the technologies and everything directly translated between new space and aviation. The aviation industry is slow and cautious, which is a good thing in a lot of ways. But it's also led us to where we are today, where there's two players who have kind of gobbled up everyone else in the market, and neither of those companies can deliver products to schedule or can really deliver any innovation. And the whole world, quite seriously, is hurting from it. 4 billion people a year get on passenger airplanes, and that's 4 billion people a year where higher ticket prices affect them, where travel delays, where cancellations, and everyone has experienced this at some point or another, almost. When we started looking at some of the new manufacturing technology that was out there, we realized that we had a chance right now to adopt it before any of the other primes could, because we have some pretty good insights on how to combine like the rapid prototyping with more enduring with materials like composites and um some other more reliable building methods. So one of the biggest concepts that I kind of picked up in the space industry is this idea of software defined tooling, where instead of in the past, you'd have really big, like fixed tooling, big giant jigs or
Hmm.
molds, that, are each built that take, months to over a year to build sometime and cost hundreds of millions of dollars. The space industry, in particular Relativity, adopted using it started using these very large robots for 3D printing, and so they could print any kind of arbitrary shape on their printers. And I was watching them print. I watched them print like the nose cone and the fuel tanks and the fuel domes and barrels on the same machine without, and all they changed was a few lines of code. While we're not 3D printing the rocket, we started to realize, well, this kind of concept of how you're like putting all of your complexity into sort of the robots and into the software that actually like builds parts like molds and jigs and tools. That is a monumental cost savings that allows you to build really exciting, really experimental and very exotic shapes with your airplanes. And there's sort of a dawning of this idea that came to me over a couple of weeks at a time at Relativity, where I realized that, wow, this technology lets us build exotic aircraft that current manufacturing just can't quite
Hmm.
produce reliably and repeatedly at scale.
So how does that make you guys different? What are you building?
So our airplane is a mid-market passenger airliner. It's a 767, 757 sized replacement. But we are using a blended wing body profile, and we're bringing in modern, higher performance electronics and avionics systems that have been developed and proven out on launch vehicles like Falcon 9 and Starship and Terran 1. And um, by doing that, we're able to build a plane that has the range and payload of a 767, but does it with the fuel consumption of a 757. So we're
Mhm.
burning about half of the fuel of the large wide body aircraft that we
Very
replace.
cool. Yes, that's huge. So sustainability, a big, is that an important factor for you guys then?
It is a lot. The immediately we have this huge reduction in fuel burn, but other parts of it we wanted to remove. There's other things that like help sustainability in aviation. We're moving towards more recyclable materials and more
Mhm.
reusable processes. Carbon fiber production has tons of waste in uh, material supplies, in scrap and consumables. And so part of what our technology does is it allows us to actually like um, reduce the amount of consumables and the amount of waste in the composites manufacturing process. And then because we're printing our molds out of recyclable parts, we can actually go ahead and after we've built a mold, and if we need to scrap it or get rid of it, we can shred it and reuse it in the same kind of printing process, which is kind of a cool longer term
Yes.
thing that we're looking at.
Very cool. Yes. I love that. Okay, well, I'm going to shift to Ian for a moment because if
That's
people
fine.
couldn't tell, Jake
That's fine.
is
Yeah.
like the hardcore engineer, super techie. And actually, I love that you're usually fiddling with something. Yeah, I think the last time we were on a call, he had like a lighter. I don't even know what he's doing. He's got his like his little things that he has, and I love that because you're always thinking about building, and you're I think you were wiring something on another call, which was really great. So it's just like your brain is always going, and it makes me happy. So but Ian, I would love to talk to you a little bit about, about Outbound and then your vision for it and have a space to kind of talk about what you think it looks like.
Sure. So you asked a couple questions that I want to circle back around on, and you asked specifically, what is it that we're doing that makes a difference? And I think I really want to pull at the thread of iteration. When you look at the aviation industry, they have in the recent history had this concept of you build it once, you build it right. And that exists for a lot of reasons, many of which are good, but are very dependent on this history, this thinking that you can't mess up because it costs too much to do that.
Right.
And I mean, physical money costs too much. And if we look at a modern manufacturing capability that allows us to build airframes at scale for reduced costs and allows us to test them in a way that is safe and is very cost effective. Now, all of a sudden, the iteration capability, and by which I mean actually building physical products, learning something, and moving forward very, very quickly, the rate of that goes through the roof. And that's where all the learnings that are necessary to actually build something right occur. And so we see this history recently where industry has tried to build something right the first time and has struggled to do that.
Mhm.
And on the other side of that, we see, a new space that said, okay, we're going to build a rocket, but the first time we build it, we know something's going to go wrong. And that's okay because what we get out of that is a massive amount of data that tells us so much more than if we spent 5 years and the cost of 5 years, man hours, simulating and thinking about it. And instead of
Mhm.
doing that, let's just go build it and learn and then move forward. And in 3, 6, 9 months, you're moving so much faster than everyone else around you. And likewise, we see that in other industries, right? In the medical industry, we see them iterating very quickly and prototyping before something ever touches a patient. Or in the automotive industry, right? They test vehicles very, very quickly or new engines, right? And so there's this interesting thing that happened in aviation where they kind of stopped doing large scale tests because there was an assumption that it cost too much.
Right.
Um, and that was true, but it is no longer based off of the technology that we're building.
I love that. That's a great answer. To that end, I want to talk about Steve, if you guys are okay
Yeah.
with it, because I love the name, and I also would love you just tell the audience about Steve. And no, it's not a person.
Steve is our first vehicle on our iteration pathway. We have 4 vehicles on our path. Steve's the first one. Steve is a 22-foot wingspan, about 300-pound vehicle that is an eighth scale. of our full-size Olympic airliner. And it allows us to demonstrate that manufacturing technology I was talking about, wherein we went and built, in the style of a full-size aircraft, this large UAS drone, essentially, in the style of an airplane. And we did that in 9 months for about $100,000 on vehicle. That's a cost and a speed at which I don't think exists anywhere else in the history that in the industry that we can find. And so when you're talking about doing that, and we could go do that again, we could do it faster now that we've done it once,
Right.
right? But we're not going to. What's next is to actually scale up and go about double the size. We're going to go to a 50-foot test bed now that allows us to take that manufacturing technology, demonstrate it on a larger scaled up version, as well as start testing the systems that we're building to go on the aircraft. And that's a large 50-foot blended wing style test bed aircraft, essentially.
What's the name?
Big
Top
Steve.
secret.
Okay, top. Okay, all right. We'll call it Tom Cruise. It's like Maverick or something. We'll have to like pretend it's the name.
Yes, Big Steve.
There you go, Big Steve. I love it.
Yeah, if I can add, so
Please.
Steve, the sort of like main the best example of a blended wing body demonstrator aircraft is the Boeing X-48, which was built and flown throughout the 2000s in a partnership with Boeing and NASA. It took them several years, and they built a large, about a 21 or 22 foot scale gas turbo kerosene jet powered demonstrator, and that plane weighed around 450 or 500 pounds, and it was used to do all sorts of like flight control testing and aerodynamic proof testing. It kind of validated in a lot of ways the blended wing body platform. And what we wanted to validate was our ability to build that same airplane years faster than Boeing and for much lower cost, while demonstrating novel carbon fiber manufacturing technology. And so we did just that in about 9 months.
I mean, that's incredible, to be honest. I know how hard you worked, you and your team. So, I mean, that was really, really well done.
I want to pull on what you said there. One of the most important things that we have to do and are doing already is building this incredible team. And I'm so, so proud of what they did and pulled off. We have 5 full-timers and then about 10 other people who've come in and helped us in some capacity or another, including taking weeks off of work to come help us, because they understand and are just so excited by this vision of building a next generation vehicle. And so I'm so thankful for them, and I just want to make sure that they get a proper shout out.
Actually, talking about the team, I think a lot of folks in this startup community, would be interested in hearing your founder story because you are 2 co-founders, and I think a lot of people are looking for a co-founder. They're interviewing for a co-founder. How did you know that Jake or Ian was the right co-founder for this? And what is your guys' story a little bit? And also, if you could dig in a little bit on why you're complementary to each other, because I know that you guys work great together. I'd love for you to talk about it a little bit for the community.
Yeah, I will try to shorten what is a
Sure.
15-year uh, brotherhood, I guess. So Jake and I went to college together. We were part of founding a team in college that we took to a world championship several times. It was a robotics team. And there were a number of us on that team that kind of circulated ideas constantly and still do. And at about 2020, I reached out to Jake with yet another idea and said to him, why don't we just go build an airplane? Why don't we just build a 737 replacement? And fully honest, full disclosure here, Jake just laughed at me and said, like, there's no way you can do that, right? That takes, 20 years and $50 billion, and no one can do that except Boeing and Airbus. And
Mhm.
at that point, I was transitioning between a couple different companies and projects that I was working on, and had this kind of depth of understanding of manufacturing that was good for not aerospace, but I knew that there were problems in the aerospace industry.
Mhm.
And so I was like, I don't know aerospace to say if you're right or wrong, but you, Jake, right, you are the airplane guy that I know. And I mean that quite seriously, that Jake is this like airplane, he's going to kill me, but genius, right? That just like he can recite crashes from memory. He can recite like everything about an airplane. I was like, look, Jake, I think there's an opportunity here.
When Ian asked me about this, I had spent about 6 years at Boeing at this point. And I'd worked on a number of different commercial planes, and I'd also worked on the CST-100 Starliner. And so, the Boeing takes 10 years and $10 billion to do just about anything. But I started thinking about how like the SpaceX Dragon capsule and the whole like Dragon program went compared to the Starliner program. We had the same set of design requirements. We had roughly the same budget, and SpaceX just kind of blew Boeing out of the water in every single way. While the Boeing sort of line on the whole program was, we're the best in the industry. No one else knows what they're doing. We'll get here before anyone else. And so I started thinking, wait a second, if this is what they said about spacecraft, maybe that's true about aircraft as well.
Mm,
And maybe that, well, so what are they doing in the space industry to do better? And so I ended up leaving Boeing and I went to Relativity, and I worked on this new rocket program there, and kind of like worked and lived with a lot of people who had built SpaceX rockets,
right.
people from the original SpaceX, people from the Dragon program and everything like that. Um, and I started to pick up exactly what it was. And after a couple of years there, and I had this realization about um, how they manage tooling and how they manage design and engineering, and a couple of other really cool aha moments for me. Um, I called Ian back and I said, "Hey man, maybe you were right, and maybe
So
we can do it a
meanwhile,
lot
Ian's just
faster."
waiting for like 4 years for you. Is just to be
Maybe.
clear, like I want to get that right. Like he
We
No,
we
so
continued talking,
yeah.
but maybe. I
Yeah,
don't know.
that's
What were
that's
you
I mean,
doing
I
those
love that,
those
right?
years?
I feel like that's important to call out because it also means like, what something's meant to be, right? It might not be right now, but it might be in a couple years and then it's like really takes off. And I think that's an important point because sometimes people try and force it in the right now when maybe it's not the right time.
Yeah, there was definitely learning that had to be done. I mean, look, any founder who tells you they know everything going in is wrong, right? Like there was learning that had to happen before we started, and learning that has happened once we started and continues to happen every day on different elements of the business and technical and all of that process. Um, so while Jake was out learning about the new space industry, I was actually in the medical industry at that point, bringing a couple new products to market, helping develop, productize, sell, patent a whole bunch of different things in the medical industry, which is actually very interestingly quite adjacent to the way that the aviation industry thinks about working with a very intense regulator,
Right.
thinking about how they go about a process for safety, productization, and that whole chain there. And that's where a lot of my background in the manufacturing and capability was that I then brought back into this. So Jake, or sorry, Molly, you asked about where do we find complementary action between the two of us. So Jake is this like technical, deep, capably expert, right? That just can absorb large amounts of airplane data and turn it into anything you need to know. And on the other side of that, I like to think of myself as the guy who puts people in a room and makes them work together.
Mhm. Makes
I
them
have
or like encourages them. Like I love the like
helps them,
yeah, there you go.
helps them. I like to be the guy that finds the right people, puts them in a room, and helps them work together as efficiently and as quickly as possible. I am an engineer by training, and I can do all of that work, but I have always much more appreciated and understood the skill set of helping people work together really, really well and really efficiently. And I'm just so excited to be doing that in this company now.
Hmm. No, I love that. Thank you. You're gonna say something, Jake?
I've been an airplane guy forever, for my entire life, for as long as I can remember. And it's part of why I went to college. It's why I went into engineering, and it's why my first job out of college was working at Boeing in Phantom Works there. Um, and I've always just wanted to build airplanes, and I wasn't able to do it at Boeing. And then I left Boeing and I went to the rocket industry, and I still wasn't building airplanes there. And rockets, frankly, are a lot more boring than airplanes. But I knew that when I was, when I was looking for co-founders, when I started having this idea, when I was looking for co-founders about like, who's out there, Ian and I have already built teams together and successfully led them
Yes.
to
Yeah.
victory. And I knew that like, if there's someone else in the world that like I could trust to do the same thing with me, it was Ian. And I bring a lot
I
of
like drop like a
knowledge.
little heart down on the screen, like, oh, heart.
I yeah. I bring a lot of like airplane knowledge into things,
Yes.
but that's kind of where, I don't want to say that's where my knowledge ends, but like that's my thing is sort of the
Yeah, you're
technology and
passionate
the
about it,
engineering
and that's
side. And
great.
Ian does a
Like I
great job of Ian's been
yeah.
putting together the rest of the team and building and building out the organizational infrastructure and like so we do it and building out the operational environment for all of us to work in, and that's awesome.
We have to have the dreamers and we have to have the people who make the dreams happen, right? Like there needs to be like those two, like at least in my own life, I found that to be true. Like, you can like, okay, we're going to do all these things. And then there needs to be the person that can operationalize it and say, we're going to take it this step at a time,
And
right?
I like that for both Ian and I, we each have like half of that, but the other, we each have like the opposing halves of those, both of those kind of mindsets.
I love that.
And so I think that's why we work so well together.
That's
And
good.
just to give you an example of those halves, so we're currently in a preliminary design of one of our aircraft, and we spent about 6 weeks working on the outside of that aircraft. And then let me tell you, Jake had every single input you could have about what's right, what's wrong, and what needs to be better. And I'm like, that's the way it should be, right? And then as soon as we got into the interior, about hey, where does passenger comfort come in, and
Mm.
what's the user experience look like, and how does the flow and the pathfinding of the interior of the cabin happen? And Jake's like, hey, Ian, you're in. I'm all in, and I want to talk about that all day long. And so here's this very dichotomous aspect, and yet we still work together every day and are very excited to do it.
I love it. Okay, well, I'm going to ask another hard question and then we'll start to wrap up. But this one I'm excited about. So, okay, you've got your startup. what how's it going, right? Like I would love to hear like the not so good parts and the good parts too, right? Just for people who are in the audience who are maybe going through this process too, and just kind of like what have been your challenges and what have you been your big successes?
I think my biggest challenge is just that no one tells you what to do. And that's good and bad. You know, I went into that knowing, I'm my own boss. No one can tell me what to do. But like, as an engineer, I've worked as an IC for my whole career. Or in like, low level leadership roles. But like, I had never been in a position where like everything was a completely clean slate. And quite frankly, no one has successfully started an aviation startup before. At least not in the level and in the direction we are trying to. And there's not really a clear roadmap. And um with the ultimate goal of building commercial airliners, there isn't a way to get there. If I was starting a rocket company, I'd have examples in front of me. If we were starting a robotic car company or EV tools, there's a pathway there. But every single startup has a completely unique path, and every single startup has things like no one has done this before. What am I going to do here?
Mhm.
And I was not used to that. Having no support there in the way that you do as a founder. But you got to figure it out.
Yeah. 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 Ian, how about you?
uh, I think probably the hardest and most exhilarating thing about everything that we're doing is it's a fire hose. Um, I love jumping into the the action and figuring out what's going on, how to fix it, and moving forward as quickly as possible. And let me tell you, that's exactly what a startup is, and it's not just once in a blue moon; it's every single day. Is what is right, what is wrong, how do you isolate and understand those elements, move them together, move them forward, and that is incredibly difficult and very time consuming and exhausting.
Mhm.
And it is also exhilarating because you're solving problems at the speed of as fast as you can.
Right.
And I love that. And yeah.
No, those are good answers. Okay, and I'm going to end with what are you currently reading?
So I have like 3 or 4 books that I'm in the middle of. Here, I've got 2 of them right here. One is The Hard Thing About Hard Things, which is a famous one that Jake gave me. This is a translation of some poetry by Gunnar Harding,
What? I love
that's
that.
guarding the air. I'm looking for some interesting history about. It, anyway,
The
so
poetic
some,
founder. I like that. I think that's the
and then a couple of parenting handbooks, learning how to figure out that problem as well.
That's great. How about you, Jake?
I've been sitting here trying not to give the Aziz Ansari answer of like I read the internet and I'm a million pages into the worst book ever. I spend most of my time reading academic papers. Actually, I recently found some new ones on London wing body structures that I
Love
was
it.
reading through. But every couple of days I have a different paper that I'm reading and following up on, which is a lot less exciting than Ian's answer, I think.
I think everyone reads different things, right? And it just depends. I mean, I've had so many different answers on the show. As we kind of close out the show, I just want to let everyone know that we'll drop links for Outbound in the video description so people can go and visit and see what they're doing. And if you want to get in touch, are you guys open to connecting and meeting people and discussing kind of some of the things you're working on?
Yeah, send us an email
Yeah.
at hello@outbound at outbound.arrow.
Thank you guys very much for being on the podcast. It was really an honor to have both of you here today.
Thank you, Mollie.
Thank you.